You are welcome to another wonderful edition of School on Air, dear students at home. And today, in physics, we'll be talking about inclined plane. We'll continue from where we stopped the last time, when we were talking about machine. You will recall that in the last time that we were in class, we talked about mechanical advantage. And I told you then that mechanical advantage has to do with the load all over effort. The last time we were in class, I talked about the fact that no machine can be 100% efficient because of loss of energy due to friction. And then I said it also that this is also based on the second law of thermodynamics, which states that in any energy conversion from one form to another, there will definitely be loss of useful energy. Therefore, no energy transformation can be 100% efficient. So we continue from where we stopped last time. Today we will talk about inclined plane. And to start with, by the word inclined plane, what does it mean? The inclined plane is used to lift heavy loads into vans or trucks. Examples are a slope, a hill, a ramp. When we talk about inclined plane now, we are talking about a device that can be used to lift heavy loads. Either when we want to offload a van or we want to take away loads from the back of the vans or trucks. And generally now, inclined plane is more or less like in form of a kind of right angle triangle form. You can see the diagram that is on the board, the picture that is on the board now. You can see that man is actually trying to place a load at the back of that truck. And so actually now he was exerting force on that load to push the load forward into the back of the truck. And the essence of doing this is to facilitate ease of movement of that load to the back of the truck. And that's exactly what we talk about when we talk about inclined plane. Then, like I said now, examples of inclined plane also include a slope, a hill, and a ramp. In case of a ramp now, most times now you have vehicles that also have a ramp that will facilitate the ease of movement of handicapped people, making it easier for them, especially those who are on wheelchair now, to be able to come down from a vehicle or alight from a vehicle. So the inclined plane now is actually used to either lift heavy load to the back of a truck or to offload loads from the back of a truck. But generally now in inclined plane now, the velocity ratio of an inclined plane can be given as the distance moved by the effort divided by the distance moved by the load. So at a glance now you will see that the velocity ratio is more or less a ratio. The ratio of the distance moved by the effort and that of the distance moved by the load. So the velocity ratio is distance moved by effort all over distance moved by load. But generally by effort now we mean that the force that is applied to the body to push it through that distance. And distance moved by the load is the load on which the effort is actually applied. But we can also relate this velocity ratio in another form. We can also have another form or another kind of definition of velocity ratio. It can also be defined in the light of the length of inclined plane, the length of that inclined plane divided by the height of inclined plane. By the length of inclined plane, we mean the slope part, that part that is more or less representing the hypotenuse side of the hypotenuse side of the triangle. So the velocity ratio now is the length of inclined plane divided by the height of inclined plane. So then the other thing is that we also know that the velocity ratio is the length of inclined plane divided by height. We can relate this since we know that the length divided by height in that case, if we assume that the triangle is in form of is a right angle triangle, we know that it's going to be equals to sine theta, where sine theta is equals to the opposite all over hypotenuse. And more or less now, when we look at that now, knowing fully well that the velocity ratio is length divided by height, then it is going to be the reciprocal of the sine theta, which is 1 all over sine theta. That's going to represent the what? The velocity ratio. Because you know that if sine theta is equals to the height all over length, then the reciprocal of that sine theta, which is 1 over sine theta, will definitely be equals to the length all over height. But that is not all. In the case of a frictionless inclined plane, by frictionless inclined plane, we are talking about when two surfaces are in contact and you don't have friction at all, which means that there won't be any energy loss as a result of friction. And that is saying that whatever effort that you are putting in now is going to be what your input must be definitely equals to the output. But you will recall that I told you that no machine can be actually construct. You can't have a machine that is in that form. That is a machine that is 100% efficient. But for the sake of argument now, let's say that we are talking about a frictionless inclined plane. Definitely the velocity ratio will be equals to the mechanical advantage. You will take note of the fact that we said that for a frictionless inclined plane is an inclined plane where there won't be any energy loss through friction. So in that case now, the velocity ratio will equals to the mechanical advantage. And you will recall, like we proved, that the velocity ratio actually is equals to 1 all over sine theta. Definitely, if velocity ratio is equals to the mechanical advantage, then the mechanical advantage will also be equals to 1 all over sine theta. But then we can also move forward by looking at the work output. So because when we are exerting our efforts now, we are putting in effort, we are putting in work, we are putting in energy. So the work output definitely now, that is what we are going to get as a feedback out of what we are putting, will be equals to the load multiplied by the distance moved by the load, which is definitely also equals to the load multiplied by the height of inclined plane. So the work output is length times height, and the work input is effort multiplied by the distance moved by the effort, which is also equals to effort multiplied by length of inclined plane. But you will recall that we said that in the case of a frictionless inclined plane, then what we are putting in, which is the work input, will be equals to work output, which means that if you are putting 100% amount of energy now, you are going to get your 100% back. And definitely this is not possible, because we know definitely that if you start a device now, part of the energy will be lost as useful energy. Let's take for example now that we have a kind of candle. You have a candle in your hand, and that candle now the candle generally is having a chemical energy. So definitely now what you need in that candle is the light coming from that candle for illumination. But along the way now, if you place your hand around that candle, you will feel the heat coming from the candle. The heat is a loss of energy, because that energy coming from the candle, the heat, is not what you need. What you definitely need from that candle is the light. So meaning that you are changing the energy from chemical energy that is present inside the candle to the light energy, and you are also losing energy in form of heat. That's exactly what we are saying, that if you are changing energy from one form to another, there will be loss of useful energy. So but in this case now, when we talk about a frictionless inclined plane, like we said, the mechanical advantage will definitely be equals to the velocity ratio, and the efficiency will be equals to 100%. More so, efficiency of an inclined plane now, when it is going to be equals to the work output all over work input multiplied by 100%. The efficiency of an inclined plane equals to work output divided by work input multiplied by 100%, which is definitely equals to the load all over effort multiplied by the height all over length multiplied by 100%. So generally now, the efficiency is going to be LH divided by EL multiplied by 100. But you will take note of the fact that if we are definitely talking about a frictionless inclined plane, since the mechanical advantage is equals to the velocity ratio, and the efficiency itself is equals to mechanical advantage over velocity ratio times 100. If both of them are equal, mechanical advantage divided by velocity ratio, they are equal. Definitely when they are equal, then they are going to be, their division will give you 1, which means that you are going to have efficiency being equals to 1 multiplied by 100% for frictionless inclined plane. But for those inclined planes which are realistic, which we know, where the energy, the efficiency cannot be 100%, the efficiency is definitely going to be equals to the work output. That is what we get as feedback divided by work input, what we are putting in, multiplied by 100. And we can relate this one in the light of the load all over effort multiplied by the height all over length multiplied by 100%. So now, for the sake of adequate understanding of what we have been talking about now, let's quickly look at the example that is on the board. You take note of the example. We said an inclined plane of angle 15 degrees. So in the question now, we are talking about an inclined plane. You can see that. And the angle of that inclined plane is angle of 15 degrees. Is used to raise a load of 4,500 Newton. We use an inclined plane of angle 15 degrees to raise a load of 4,500 newtons through a height of 2 meters. If the plane is 75% efficient, calculate 1. The velocity ratio of the plane. 2. The work done on the load. You will take note of the fact that, like I used to tell you now, the first thing that you need to do when you are given any calculative work in physics is to identify those parameters that you are being given. In the question now, we are given the angle of the inclined plane, and you can see the angle there, which is there, 15 degrees. We are also given the raise the load. The weight of the load now, the force on the load now, which is 4,500. You can see the load now, which is 4,500 Newton. That's the weight of the load. And then we are also given the height of the inclined plane. And you can see the height of the inclined plane now, which is definitely 2 meters from the ground. And then we are also given the efficiency. The efficiency of the machine is 75% efficient. By that 75% efficient now, we definitely will know that in this case now, we are not talking about a frictionless inclined plane. Because in a frictionless inclined plane, definitely the efficiency will be equal to 100%. So now what we are asked actually to determine the velocity ratio of the plane as well as the work done on the load. How do we go about this? Like I said now, you list out the parameters you have been given, and those parameters that we have been given now are listed out, as you can see on the board. But knowing fully well that the velocity ratio is equal to 1 over sine theta for an inclined plane. The velocity ratio is the reciprocal of sine theta. That is 1 over sine theta for inclined plane. We will definitely be able to determine the velocity ratio by saying 1 over sine what? What is theta? Theta is 15. And definitely 1 over sine 15 will give us 3.86 as the velocity ratio. More so, we are also asked to determine the work done on the load. We are supposed to determine the work done on the load. But we know that when you are doing the work on the load now, that's exactly what the work input. The energy that you are putting into the work that you are doing is the work input. And definitely now, the work input can be determined by using the formula for efficiency. Knowing fully well that efficiency is equal to the work output divided by work input multiplied by 100%. And the work input now is also equal to work output. If you all by efficiency, mathematically, if you cross multiply, you will see that this work input coming up, we put efficiency on that. So a work input is equals to work output divided by the efficiency multiplied by 100%. So what is the work input? Work input is also equals to the load multiplied by the height, because we know work output is load times height divided by what? Efficiency. So this is to actually introduce the work output. Work output is load multiplied by the height of the plane divided by efficiency multiplied by 100%. And we can have that. Since we have been given the load, which is 4,500 newtons, and we have been given the height, which is 2, we can multiply by 100, which is the percentage there, divided by the efficiency, which is 75. At the end of the day, we have the work input being 12,000 joules. But there will be instances when you will be asked to put the energy in form of kilojoules. You will take note of the fact that 1,000 joules is equals to 1 kilojoule. So in this instance now, 12,000 joules will definitely be 12 kilojoules. Joules being the unit of energy. So generally now we have talked at length about a lot of things today. We've talked about the inclined plane. And we said that inclined planes are quite important in actually taking load from the back of vehicles, in carrying loads from one place to another. And we said also that in case of inclined plane now, we have what we refer to as a velocity ratio. We talk about the mechanical advantage and so many other things. And we said that the inclined plane also have a lot of application in our day-to-day usefulness. We talk about the case of ramp. We talk about the case of workers trying to work in factory, carry loads from one place to another. Or in case of construction sites now, people trying to drop heavy load, roll heavy load or drums down an inclined plane. So generally now, in summary, we've talked about the fact that the inclined plane is used to lift heavy load into vans or trucks. We use inclined plane to lift heavy loads into vans or trucks. And we also be able to talk about the fact that the velocity ratio of an inclined plane is given by the distance moved by the effort divided by the distance moved by the load. It's a ratio. So the ratio of the distance moved by effort to that of the distance moved by the load will definitely give us the velocity ratio of an inclined plane. More so, this is in the same. It also is equal to the length of inclined plane, and I told you that the length of that inclined plane is the slant side, or the side that we refer to as the hypotenuse of the inclined plane divided by the height of that inclined plane. It's also equals to the velocity ratio, and I told you that the sine theta of the inclined plane is equals to the height all over length, and the reciprocal, that is 1 all over sine theta, will definitely be equals to length all over height. And if length all over height being the velocity ratio, then 1 over sine theta is also the velocity ratio of an inclined plane. So generally now, I hope you have been able to learn one or two things about, one, that the velocity ratio of inclined plane is 1 over sine theta, and so many other things. But before we go there, students at home, let's quickly look at that. We talk about this, that the velocity ratio for frictionless pulley is equals to mechanical advantage, which is also equals to for a frictionless inclined plane is equals to 1 over sine theta. In that case now, both the mechanical advantage and velocity ratio are equal. But before we go, I want you to quickly take note of the assignment that is on the board now. It says, a plane inclined at 30 degrees to the horizontal has an efficiency of 50%. Calculate the force parallel to the plane required to push a load of 120 Newton uniformly up the plane. So dear students at home, we've come to the end of today's episode. I hope you'll be able to learn one or two things. Join us the same time next time when we continue on this topic. From me, have a nice day.